we are discussing about the various types of multiplexer related questions that was come in previous MAKAUT examination, and I think among these 2 or 3 video I will try to solve at least 10 problems, and among the 10 problems in the coming semester it will definitely come. So keep the video minutely, and if you complete the multiplexer part then you can skip this. Okay, so the first question is implementation of 4:1 marks using the 2:1 marks. So I have already told you what is mask. So marks basically nothing but multiplexer is nothing but one kind of data selector. That means there are many input and one output, and the inputs are dependent upon the select line. That is, the if n number inputs are there, if n is the number of inputs, so n to the power m will be represented, that m become the number of select line. That means if there are 8 input, so 8 can be represented as 2 to the power, that means it become, you can take this become 2 to the power m. That means you have to show that input in the form of 2 to the power something. So 2 to the power 3 is nothing but the 8, so 3 is the number of select line. Like that, if there is a 4:1 mask, that is the 4:1 marks, it means that 4 input and 1 output. It means it has a select line. How many select lines are there? It is 2 to the power 2 become 4, because n is the 4, so 2 to the power 4, that the 2 to the power 2 is the 4, so 2 is the number of select line. It means that we have to implement a 4:1 marks using the 2:1 marks. So first of all, you have to know that how much 2:1 marks is needed for building a 4:1 marks. So it's a very simple. That means just 4, you have to build 4:1 marks, and with the help of 2:1, so you have to divide 4 by 2, it becomes 2, and again then 2 by again divide with 2, it becomes 1. So the number of the 2:1 marks required is 2 plus 1 is equal to 3. That is the trick, you have to keep it on your mind. That means we are going to, so I can erase this, we are going to draw 3 2:1 marks by which we can implement a 4:1 marks. So first all of you draw, this is your, take a straight line. So this is your 2:1 marks. It has 2 input and 1 output, and it has 1 select line because 2 is represented by 2 to the power 1. So this is a 2:1 marks, and here we are taking another 2:1 marks because I have already shown you that the number of 2:1 marks required is 3. So these 3 are the 2:1 marks. Write it 2:1. This is also 2:1, and this is also 2:1. Now that is, the inputs are 2. That means if the inputs are, and the select line is 1, this is your select line. Okay, now so these select lines are become I0, I1, I2 and I3, and this is your output Y. Now if you draw the truth table for it, then it becomes, the select line should be S1 and S0 because the output is 2. It means if this is another select line, so the select lines, how you have to choose the select line, which one is S1 and which one is S2. So S1 and S0 are the select line, and depending upon that we are getting the output Y. What are the possible combinations? 0 0, 0 1, 1 0 and 1 1. So for it we can get I0, then I1, then I2 and I3. It means when S0 and S1 both are 0, then we are getting Y as output, I not as output. Y it is 0 and 1, it becomes I1 like this. Now we want to get I0. So if we want to get I0, what should we do? We should select that it becomes 0. If it becomes 0, then, and if this 2:1 marks are connected with the third one, then as it is 0, then it is also 0. Okay, so it means that I0 is selected from this marks and I2 is selected from this marks, because this is 0. 0 means 2, 1 means 3. Okay, so here again we are taking 0 to select the I0, because if it is 0 then it is I0, if it is 1 then it becomes 0. Now 1 I0, that is I0 we are getting. Now the second point is that we want to take the I1. How should I take I1? So for I1 we should take it as 1. If we are take it as 1, then this become I1, and if we are if it is 1, then this is also 1, and if it is 1, then this is selected I3. Now this is I1 and I3. We have to select the I1. Again we have to select the 0. Now consider this and these 3. Consider these 3 terms. When it is I0, then S0 and S1 both are 0. So it means when when S0 is 0 and 1, when S0 is 0 and 1, we are getting I0 and I1 in both the cases. So it is 0 and 1, and for that we are taking I0 and I1 both the cases. So this is nothing but the S0, and this select line is nothing but the S1. So this is how we present a 4:1 marks using a 2:1 marks. It is very, very important. So question number 1 is already completed. Now go to the question number 2. Implement 8:1 marks using 2:1 marks. It's a not difficult, but it is a quite big diagram. It means first, so now you just select this question first and go to the next page. So this is your question. Now how should we? So now we have to make 8:1 marks using 2:1 marks. Okay, it means that first we have to choose that how many 2:1 marks is required. So for that we are taking 8 divided by 2, it becomes 4. Then 4 divided by 2, it becomes 2, and when 2 divided by 2, it becomes 1. So the number of marks required is 4 plus 2 plus 1, that is the 7. So we have to draw 7 2:1 marks first. Now just draw this is 1 2:1 marks. just make a copy, just make a copy, 3 4. Again you have to make another copy, you have to make another copy. So this become 4, this become 5, and this become, so you have to connect one mask over here, then this become 4 5 6, and we have to take another, we have to take another 42:1 marks. So this is our marks representation. Now we can easily simplify the situation. So to simplify it, first we have to write the truth table. So as it is 8:1 marks, it means 2 to the power, it means 2 to the power 3, 2 to the power 3 is become 8. It means that it has a 3 select line and 8 input. So as it everything is a everyone is a 2:1 marks, it means that it has a 2 input and all of them has one select line. So find the, after the making the diagram, so this become connected to this, and this become connected to this, and this become connected to this, and this become connected to this. Again this connected to this, and this connected to this, and this is your Y output. Now first you have to draw the truth table. As it is a 8:1 marks, then it means it has a 3 select lines. Okay, that means here one select line, here one select line, here another select line. That means if it is S0 S1 S2 or S0 S1 S2, how we can select the select line? This is the main question. So what are the inputs? I0, this is the I1, this is the I2, this is the I3, this is the I4, this is the I5, this is the I6, and this is the I7. Now all are the 2:1, 2:1, 2:1, 2:1 marks, 2:1, 2:1, and 2:1. So now we have to write down the truth table for 3 variables. How can we write the truth table? This is 1 S0 S1 S1 S0, this is your S1, this is your S2, and this is your Y out. Now take 8 column. This is 1 2 3 4 5 6 7, and this one is the 8. So here we have to write down S2 S1 S0. The combination is 0 0 0 0 1 1 1 1 0 0 1 1 0 0 1 1 0 1 0 1 0 1 and 0 1. What are the output? Output are nothing but I0. If this is Y, then Y become I0, I1, I2, I3, I4, I5, I6, and I7. Now if we want to take Y is equal to I0, what should we do? it means we have to select 0 over here. If all are the 0, if 1 is 0, then for the whole column all are the 0. Okay, they are parallelly connected, so these are 0. If it is 0, then from this I1 I0 is connected, I0 is selected, here it is I2 is selected, here it is I4 is selected, here it is I6 is selected. Now again we have to consider the I1 I0 as the output, so we have to take the output I0 over here, so it becomes again 0. If it is 0, then it is 0, so this become I0 and this become I4. Again to carry forward this I0, we have to again give a 0 over here, and we are getting I0. It's okay. But if we want to take y is equal to I1, and what should we do? Then we should give 1 over here, 1 over here, 1 and 1 over here. So then from here it is selected I1, here it is I3, here it is I5, and here it is I7. Now we have to select I1. It means we are again putting 0. If it is 0, then it is also 0. See, if it is 0, then it becomes I1 and it becomes I7. Again we are putting 0 to take I1 forward. So if it is 0, then I1 is selected. So the output is I1. It means now again you group these two. Again you make this group, and this group. So if you are considering, so it is 0 1 0 1 0 1 0 1. It means for 0 1 0 1 0 1 we are getting I0 and I1, we are getting I0 and I1. It is 0 1, and these two are 0 0, this is 0 0. So if this become S0, then this is 0 1, no problem, 0 1. If this is S1, then this becomes 0 0, no problem. And if this is S2, that becomes 0 0. That is, our goal is selected. It means that when according to the select line, that is the whatever you are choosing 0 or 1 in the first select line and second select line and third select line, depending upon that we are getting the output. So this is the implementation of 2:1 MUX using 8:1 MUX. Now the third question, it is a bit crucial question. It means this is nothing but the special case for the special case for the multiplexer. Why? I just show you, because if you minutely see through this question, you see that 8:1 MUX is there, and we have to make it by 4:1 MUX. It means that there are 4:1 MUX. Acha, okay. So for 8:1 MUX, the select line is 3, and for 8:1. For 4:1, the select line will be 2. It means there are no extra select line by which we can make this 8:1 multiplexer. It means that in 4:1 MUX there are 2 select line, but in 8:1 the select line is 3. So how can we implement the third select line in this scenario? Then we are taking one enable line which consider as a select line. Enable is 0, then output is low. Enable is, that is the output is 0. That is, we are select a enable line as third select line when enable is 0, that is output is low, that is 0. Okay, this you have to keep in your mind. Now, how much a 4 is to 1 multiplexer are there? So you have to find it. We have to make 8 is to 1 marks using 4 is to 1 marks. So divide 8 divide with 4 will become 2. Then again 2 by 4 it become 0.5. So this is nothing but a select line, and this is nothing but a number of 4 is to 1 marks. Now just draw one 4 is to 1 marks, two 4 is to 1 marks. So this is one 4 is to 1 marks which has 4 input lines and 2 select lines here, and we are taking the copy of this. So this is another 4 is to 1 select 4 is to 1, and the input lines are 4. It means here input line is I0, I1, I2, I3, I4, I5, I6 and I7, and here we are taking one notch for enabling the select line. This is the notch where we can enable a select line. So this is our notch. Now this is nothing but the 4 is to 1 marks. This is also 4 is to 1 marks. What are the inputs? This is the I0, I1, I2 and I3. This is I4, this is I5, this is I6 and this is I7. Okay. So the number of select lines should be 2. One select line, second select line. We can make select line over here also, 1 and 1 select line. Now there are the outputs, and output is connected with a OR gate. I will give the explanation why the OR gate is required. So this is your OR gate. This is the implementation of 8 is to 1 marks using the 2 4 is to 1 marks. Now take one select line over here, take one select line like this and connect this select line with the notch. Now you just take one NOT gate over here, so take this is S0 and this is S1, this is also S0 and this is also S1, and taking that enable line as S3. Now if sorry, not S0, this is not S3, this is S2. Now again we are taking this same now we are copying this not possible for copy. Now we should draw the table for that S0, S1, S2 and S3. And this is the output line. So now make a box. This is 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so these become S2, this become S1, this become S0, and the output become Y. This is the Y output. Okay. Now, so what are the possible combination? 0 0 0 0 1 1. Pain is disturbing, sorry for that. This is the 1 1 1 and 1. Here it is 0 0 1 1 0 0 1 1, and here it is 0 1 0 1 0 1 and 0 1. Now what are the outputs? Outputs are I0, I1, I2, I3, I4, I5, I6 and I7. Now the main thing is comes over here. Now if S2 is 0, if S2 is 0, then the here S2 is become 1, and if S2 is 0, then this multiplexer is not working, and the output is 0 over here, because when it is enable is 0, then the output is 0, the output is 0. So there here the S1, S2 is 1 now. Now we choose S0 is 1 and S1 as 0. If S0 is 1 and S1 as 0, then it become, which one is selected? And S2 is 0 over here. Here the input S2 is 0 and here it is S1. So as input S2 is 0 and S1 is 0 and S0 is 1, then the output is what? Output is become, so here it is enabling, so this become I1. One thing, it is bit easier to you if you take this NOT gate over here. We are taking the NOT gate from, instead of here, we are taking the NOT gate over here. Then it is bit easier to find you. Okay, so this is one is, this is S2, this one is the here. Now taking this S2 as 0, so this S2, if this S2 is 0, this S2 is 0, then this S1 is become 1, and if S0 is 1 and S1 is 0, then for S0 is 1 and S1 is 0, and if the multiplexer is getting S1 as 1, S1 as 1, then that is the S2 is 0 over here. Now for this S1 is 1, it means that this multiplexer is working, this multiplexer is working, but this multiplexer does not work. It means that the here the, for this it is very simple. For S0 is 0 and S1 is 0, so S0 is 1 and S1 is 0, the output is 1, because it is a 4:1 multiplexer. When it is 0 0, then I0 is selected, 0 1 I1 selected, 1 0 I2 selected, and 1 1 I3 is selected. So here 0 1 is given, it means that I1 is selected. As it is S1 is 1, then S2 become 0 over here. So if it is S2 is 0, then the output of this multiplexer becomes 0, so this becomes 0. Now I0 and 0 is odd, that means Y is equal to I0 plus 0, that is nothing but the I0. Now if we are taking that, if both are 1, so if S1 S0 is also changing the color, if S0 is equal to 1 and S1 is also 1, and so for 1 and 1, for 1 and 1, for 1 and 1, and for 1 and 1, what, as, and if this becomes 0 and if this S1 becomes 0, then for 1 and 1, so 0 0, so if it is 0, that means that multiplexer is not working. So for that, this multiplexer, the 0 output is the 0, as S1 is 0, this is not S1, this become S2, I think this become S2. So this become S2. If when this S2 is 0, means in this multiplexer, when S2 is 0, so this is nothing but the S2 become 1. It means that this multiplexer works, and as, so the inputs are S0 is also 1 and S1 is also 1. For 1 and 1, the output is I7, and for here the output is 0. As S2 is 0, this multiplexer is in low state, that means the output is 0. So, Y now Y become 0 plus I7 is equal to I7. This is your desired. Depending upon that, select line S2. Again, you are taking anything. Again, if S2 is equal to again 1, when S2 is equal to again 1, then again this multiplexer comes into the picture, and as S1 is 1, so now here S2 is nothing but the 0, so this multiplexer does not work, then the output is 0. Now you are taking 1 and 1. So for 1 and 1, so for 1 and 1, when both are 1, for that the output is I3, and for this S2 the output is 0. So Y become I3 plus 0 is equal to I3. Depending upon that, we are getting the output. This is nothing but the exceptional or special case in the multiplexer, and I think the probability of this question will come is almost 90% that this question will come into your semester exam. Now, going to the questions, realize the following expression using 8:1 MUX and 4:1 and 4:1 MUX. Okay, so this is very easy question. How can we solve it? So it means that here, first of all, you have to copy this. You have to copy this. Then go to the next page and paste it down. This is your question. So this is your, what is the form of this question? This is the sum of the product. So what is the first? So in this type question, it is very obvious that this type of question will come into your examination. It is very obvious. Now what should we do? So first we have to write down the expression. That is the F is equal to A B C bar plus AB plus A bar B bar C. So we cannot solve it because this is not in the canonical form. Canonical form means where all the variables should present. Here C is not present, so we have to make this in such a way that all the forms are present over there. Now this become A B, write it on canonical form A B. Which one is missing? That can be written as C bar plus C. C is missing, that's why C bar plus C is another 1 plus A bar B bar C. Now this become A B C bar plus A B C bar plus A B C plus A bar B bar C. So these two are same, so we can write A B C bar plus A B C plus A bar B bar C. If we numerically solve it, then this become 110 plus this become 111 plus this become 001. It means the form is this is nothing but the 6, this is nothing but the 7, and this is nothing but the 1. So these are the position where should we get the output, and as it is a p sum of SOP form, so the truth table is become, if you want to write the truth table without truth table you can also do it. It is very simple. That is the, it is the 3 variable means 8, sorry for the interruptions. This is the 3 variable, ABC are the 3 inputs and F is the output. So how can we draw it? This is your A, 1, 2, 3, 4, 5, 6, 7. This one is your 8. Now erase it. Erase it. So this become A, this become A, this become B, and this becomes C. These are the input and F is your output. So write 0 0 0 0 1 1 1 1, then 0 0 1 1 0 0 1 1, then 0 1 0 1 0 1 and 0 1. And what are the output? Output is, this is nothing but the 0 position, 1 2 3 4 5 6 and 7. It means at position 6 it become 1 because it is a SOP form. So at that point, at that position, or they are the 1. If it is POS form, then at this 6 7 1 position it becomes 0, and 7 position and the first position. These 3 are the 1 and else other are the nothing but the 0. So this is your truth table. Now by 8:1 marks. So we can erase it because we need more space. So we can erase it. The position is 6 7 and 1 we have already defined. Now draw 8:1 marks first. It means it has 8 input and 1 output as well as 3 select lines. So 8:1 marks. The inputs are 1 2 3 4 5 6 7 and 8, and 1 pin is obviously grounded, and select lines are A, B and C. Okay. Now this is nothing but the 0 position, 1 1 2 3 4 5 6 and 7 position. This is your ground, this is your A, this is your B and this is your C. So if we are taking a 5-volt line, if we are taking a 5-volt line that is connected with the battery and one grounded line that is nothing but the 0 volt. So write it. It is a 5 volt line. Now which one is connected with the, so 1 means the active high means the 5 volt. So 1, 6 and 7 are connected to the 5 volt line. So 1 is connected, then 6 is connected, and then 7 is connected to the high voltage line, means the 5 volt line, active high line, and rest are connected to the ground. So this is nothing but the interpretation of that this AB C bar plus AB plus A bar B bar C in with the help of 8:1 mask. Okay. Now go to the minutely observe that the using 4:1 mask. This is quite difficult. Now, so what is the truth table? First you draw the truth table. Okay. So I can erase this thing. I can erase this thing. Again draw this table, because the table format is same, but there we need some more space because we need some grouping over here. So we have to draw the table first. So this is our A, this is our A, this is B, and this is C, and this is obviously F. Now write the zero, 1, 0, 0, 1, 1, 1, then 1, 0, 0, then 1, 0, 1, then 1, 1, 0, then 1, 1, 1. Okay. Now what is the output? Output is at the position 1, at the position where we are getting, at the position where 1 we are getting 1, at the position 6 we are getting 1, at the 7 we are getting 1, and rest of that we are getting 0. So this is the 0, 0, 0, 0 and 0. So this is the truth table for the 4:1 marks. Now we have to write down the truth table for two variable. Truth table for two variable. Now if you see minutely, these A and B, this group is 0. So we are taking these two as a select line. And again, so just draw a multiplexer first, 4:1 multiplexer first. So we are This is a 4:1 multiplexer. So the select line should be 2, and the input line should be 4. And this one is the ground line. Now what should we do? Taking A and B as select line. This is A and this is B as select line. So if A and B, here in this group A, B both are same. In this group A and B both are same. In this group A and B both are same, 1 0 and 1 0, both are 1 0 1 0. Only C is changing, and in this group A and B both are same. Now how can we write the two variable truth table? So if we write the two variable truth table, we just erase this thing first. So the two variable truth table become, if A and B are select line only and F is your output, then how should we write? So this truth table, taking these two group as 1. So in first two case A and B both are 1. At that time C is 0, then F is 0. C is 1, F is 1. Means that whatever the input C, input of C, that is nothing but the output. So C is your output. Again, in the second case, A and B both are 0 and 1. So A and B are 0 and 1. Then for 0, for C is 0, it is 0. For 1, it is 0. Means whatever the input of C is, the output is nothing but the 0. The third case, for 1 0, when A and B are 1 and 0, then for 0 it is 0, for 1 it is 0. Means whatever the input C is, the output is 0. And the for fourth case, when both A and B are 1, A and B both are 1, then when C is 0, then output is 1. When C is 1, output is 1. Means whatever the C is, the output is nothing but the 1. So this is the truth table for the 4 variable. So this is 4:1 MUX. Now, so where we should get the 0. Now when, so this is your F. Okay. Now, so 0, when A, B is 0 and C is 0. Now taking one thing, first you have to take 3 lines. One is 5-volt line, one is ground line, one is C line, one is C line, and from here we taking another C, which is nothing but the NOT. This is nothing but the NOT gate line. So here it is so this is your 5-volt means active line. This is your ground means ground line, and this is your C and this is your C bar. Now when A, B is 0, C is there. So when A and B is 0, we are getting C. That is nothing but the C is connected from here to here. When A 0, B 1, we are getting 0. That is 0 means this line. When A is 1, B is 0, then also we are getting 0 as output. So again we are connecting 0 as output. So this is 0, this is V, this is C, and this is C bar. And when both A and B are 1, then we are getting 1. 1 means the 5 volt. So this is nothing but a 5 volt battery. So we are getting the high, that is 1 volt. So this is your representation of this circuit using 4:1 MUX. Now going to the last question. That is, you have to implement one POS Boolean expression using 03, implement of POS Boolean expression using 03467. Okay. Okay. This is also very easy. We can solve it. Now, what should we do? We should take this part into the next page. Here we should draw one thing, that is nothing but a summation sign. Here this summation gives you the max term. Okay, now we can solve it. This is how we can solve it. We just see that what is the given, that is M is equal to 0, 3, 4, 6 and 7. This is what kind of, this is nothing but the max term. Okay, max term means this is in the form of POS form. Capital M stands for max term, or this may be denoted max term, this may be denoted min term, and this may be denoted max term, and these three are the representation of this is. So it means that POS, this is SOP, and this is POS. Okay, now how should we do? What should we do? So there are 0 to 7. It means there are three inputs. As there is 3 inputs, that is the 0 to 7 means the 3 select lines and 8 inputs. So if we make this through our 8:1 MUX, it is quite easy. And as no specification is there that you have to draw it using 4:1 or 8:1, so it is quite easy, because as it is given only the expression, then you should take as 0 to 7 is the input, so you should take 8:1 MUX. You should take 8:1 MUX. 1, 2, 3, 4, 5, 6, 7 and 8, and obviously select line is 3, 1, 2 and 3, because 3 variable, 8 input means 3 variable. Now write down the variables: A over here, B over here and C over here. A is the LSB and C is nothing but the most significant bit. So these become I0, I1, I2, I3, I4, I5, I6 and I7. Now don't need to draw the any kind of truth table. This is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6 and this is 7. Now 0, so for POS it means for POS, these all these datas are connected to the 0 line and rest. What are the rest? So 0, 3, 0, 3, 4, 6 and 7 is given. It means that not given are 1, 2 and 5. It means this 1, 2 and 5 are connected in one line, that means the 5 volt plus, and this 0, 3, 4, 6, 7 are connected in the 0 line. It means we are taking the 1, 5 volt line and 1. So 0, now 0, 3, 4, 6 and 7 are connected through a ground line, that is the 0 line means the ground line, and this is the ground line, and this 1, then 2, this 1, the pen is not working properly, this 1, this 2 and this 5 are connected in the 5 volt, that is the 1, and this is the 0. This is a representation of POS phone using the 8:1 MUX. Now if you want to implement this, if it is specified that you have to implement this through a 4:1 MUX, then how should you implement? That is a big question. So to solve it, we should first draw the implementation table. What is that? So taking BC as a select line and BC, because 4:1 MUX, it means that the MUX is 4:1. So if we draw the 4:1 MUX, the MUX is like this. It has two select line, but here we have 3 variable. It means we need the 3 select line. So what should we do? We should take one thing, that is we should now draw a implementation table. By that implementation table, we can easily make a third select line. That is, how can you implement the select line implementation table? So this is your implementation table. Implementation table is like this. Now draw this as A and this as BC. So these are the B and C, and you see that B or C is taking as a select line. As it has a 4:1 MUX, then the input is 4 I0, I1, I2 and I3. So write I0, I1, I2 and I3. Now this is A bar, that means the 0, and A, that means the 1. Now the position is, it is 0 position, this is 1 position, this is 2 position, 2 position, and this is 3. According, this is 4, this is 5, this is 6, and this is 7. Now point out the positions. 0, 3, 4, 0, 3, 4, 6, 7. So it means that is 1, 2 and 5 are not written over here. So 1, this is 2, and this is 5 are not written over here. So if you draw the line, so these become, so these become, so as no circle is there, that is at the A naught and A, as there is no selection, so it become, this becomes 0, and as both are selected, these become 1, as this only 1 is selected and in front of A bar the circle is there, so this become A bar, and as no selection, so it is 0. Now for I0, I1, I2, so for I0 it is connected with the 0. It means that if we draw a 0 volt line, this is a 0 volt line, and this is a 5 volt line. Now so for I naught it is 0, so I naught is 0, it means that I naught, so I naught is 0 and I3 is 0, so you can make I naught and I3 are short circuited. We can make I naught and I3 are short circuited as both are 0, and I1 and I2, one is 1, another is A bar. So if this is, so you can erase this, thing. There is no need of 0 and 1. Instead of that, if it is 8, it is 16 very well, then it is needed. So I0 and I3 both are 0, so they are short circuited, and I1 and I2, one is 1 and another is A bar. It means, so if we draw this I1, these become 1 and these become A bar. So this is the A bar. This is how we can implement this is the circuit diagram using 4:1 in the POS form. Again, you have to draw the implementation table. So 1, 2 and 5. First, whatever the given number, it is, make it intact. Find the whatever the number is not given, the number, the 1, 2 and 5 is not given, just mark 1, 2 and 5 over there, and depending upon that you can find that when no selection are there, then we should, when no selection are there, then it is 0. When both are selected, this is 1. When only one is selected, so which one is selected? This is in front of A bar, so this is A bar. If this was the circle, if instead of this the circle is there, then you should write over here as A, and if one is selected, this one is selected, you should write over here as A bar. Now whatever the 0 0, they are the short circuited. One is the nothing but the higher volt, that is the 5 volt battery. You can take this as 5 volt battery also, and this is your A bar. So BC is the select line and A is the third line. Okay, so these are the 4 or 5 previous year solved questions, and I think I will make 2 or more questions, because by using the multiplexers we can make a adder, we can make subtractor, then the demultiplexer encoder and decoder will come. Keep watching our video. If anybody already completed this part, they can skip, but these 5 question is very important for your next year, next coming semester questions. And one thing is that we have to make of 8:1 marks using 2:1 and 4:1 combinational marks. So keep watching the videos, and the exam is in your doorstep, so study minutely and study tactfully. Okay, so again we can give the second video in 2 or 3 few days. Thank you.